Everyone and welcome. Today I'll be talking about Kirchhoff's laws. I'm also going to talk about why they are so important in engineering and where they are applied. And I'm also going to use some examples to explain these laws. I'm going to try my best to make them as simple as possible so everyone will be able to understand. Okay, so who is Kirchhoff? Gustav Kirchhoff was a German physicist and he developed these laws. So we're going to look at the laws real quick. Kirchhoff's current law. Kirchhoff's current law deals with current at a junction or a node, and Kirchhoff's voltage law deals with voltage in a closed loop. And Kirchhoff's current law definition. Kirchhoff's current law just states that the current entering the node is equal to the sum of current leaving the node. And this law is based on the conservation of charge. So this is an example. We have I1 entering the node, and we have I2 and I3 leaving the node. So the law states that the sum of the current or the amount of current entering the node is equal to the amount of current leaving the node. So I1 will have 5 amperes, and if you look at the currents leaving the node, we have I2 and I3, which are 2 amperes and 3 amperes respectively. So which satisfies this law because the sum of current entering the node is 5 amperes and the sum of the current leaving the node is also 5 amperes. And now Kirchhoff voltage law definition. Kirchhoff voltage law states that the sum of voltages in a closed loop is equal to 0, and this law is based on energy conservation, which states that energy supplied is equal to energy used. So as you can see, we have a voltage source here, a voltage source, we have a voltage drop across the resistance R1, we have a voltage drop across the resistance R2. So the algebraic sum of all these voltages in a closed loop is equal to 0. This also explains it, like I said. But now we have 10V. This is the this is we have a normal circuit. We have a voltage source 10 volt. We have voltage drop across R1 6 volts, and the voltage drop across R2 is 4 volts. So what the Kirchhoff voltage law is trying to say is that the algebraic sum of all this is equal to 0. So here we have 10 volts minus 6 volts minus 4 volts is equal to 0. So basically, I know some people are not going to understand. I'm saying sum, and they are saying positives and negatives. I know a lot of people are going to ask why don't I just add 10 plus 6 plus 5, but that's not actually how it works. You need to follow the positives and the negatives, right? So I'm going to use 2 examples to explain that. Let's say we are taking in this direction. So let's say this is negative and this is positive, right? We're going to take negative 10 plus V1 plus V2 equal to 0. Or we are going to take, like what I took in this example, plus 10 volt minus V2 minus V1. So we are going to have plus 10 minus V2 minus V1 equal to 0. So that is the origin of having positive signs and negative signs. So like they said, the algebraic sum. So you need to be very careful that a lot of students make these mistakes in exams, and a lot of students, when they get home and they try to read, they do not understand these things. So therefore, that's why I'm taking extra time to explain that. And like Kirchhoff voltage law, same thing like I explained. Okay, here we have an example. Here we have the value of the source 10 volts. We have the voltage drop across resistance R1 6 volt, and we do not have the voltage drop across resistance R2. So we need to calculate that, right? So firstly, we're going to take a loop around. We're going to have Vs minus V1 minus V2 equal to 0. Vs will have the value 10 volts. V1, which is voltage drop across resistance 1, will have the value 6 volts. And now we need to calculate V2 voltage drop across resistance 2, R2 resistance R2. So what we are going to do now is, since V1 minus V2 Vs minus V1 minus V2 is equal to 0, and now we need to calculate the value of V2. Just take V2 to the other side, and we are going to be left with 10 volt minus 6 volt, and 10 volt minus 6 volt, the answer is going to be equals to 4 volt. So the voltage drop across resistance R2 is 4 volts. And for a very important key takeaway is that the total voltage supplied by the source is equal to the sum of the voltage drops across all components in the loop. As you can see, we have the source voltage here is 10 volts, and when you add the voltage drop across resistance R1 and the voltage drop across resistance R2, you are still going to have 10 because you have 6 plus 4. So basically that's what is also very important to take note of. And for the real life use of these laws are used in circuit design, fault finding, power systems, and electronics. So these laws apply almost everywhere in electrical engineering. And summary again, just so you don't forget, Kirchhoff's current law states that the sum of current entering a node is equal to the sum of current leaving the node. And this law is based on conservation of charge. And Kirchhoff's voltage law states that the algebraic sum of all voltages in a closed loop equals 0. And this law is based on the conservation of energy. And like I've said, both of these laws are based on fundamental conservation laws. So it is very, very important to know and understand them. Thank you very much for watching. If you found this video helpful, please support by liking, sharing, and subscribing to our channel. Thank you very much for watching, and have a blessed day.